Hello, my dear students and the rest of the learners. Welcome to part 2 of a 22-part series of tutorials in Manage Database System using Microsoft Access. In this presentation, we shall be looking at identifying database models, which is part of the topic, Identify Database Concepts. My name is Meme JM, or you can simply call me Emily Swap. When we speak about identifying database models, what are we speaking about? A database model specifies the rules according to which data are structured and the associated operations that are permitted. It may also be a technique for the formal description of data structure, usage constraints, and operations. The facilities available vary from one database to another, whereby each database management system maintains a particular database model. In other words, my dear students and the rest of the learners, when you are creating a database, you should always ask yourself, which model of a database are you going to implement? This is because various software allow programmers or users to create databases based on certain models. For example, Microsoft Access Database or Microsoft Access program or application creates a database that is tailored on what we call a relational model. And therefore, you choose the database management software that you want to use in creating your database or managing your database based on the model that you want to implement. A database model is a combination of at least 3 components. These components are a collection of data structure types, a collection of operators or rules of inference, which can be applied to any valid instance of the data types listed in number 1, or at a collection of data structure types. Number 3, a collection of general integrity rules, which implicitly or explicitly define the set of consistent database states, or change of state, or both. And therefore, we have a number of database models. The most common database models are the Entity Relationship Model, or ER model, whereby or which is a conceptual diagram that represents data using entities, for example, tables, attributes, which we also call fields, and relationships, which are the connections between them, and between them using ER diagrams with entities, keys, and relational types. And therefore, my dear students and the rest of the learners, we need to be aware of what ER model is. And therefore, my dear students and the rest of the learners, when you are creating a database implementing the ER model, you are simply making use of a diagram that illustrates how the various fields in various tables within your database are going to be related. And therefore, ER model has the characteristic or the character of having fields that have a certain relationship between one table and another. So each table is related to the other table through a certain field. And therefore, we have what we call, or we generate or develop what we call the ER diagram. This ER diagram has various or has 3 main characteristics. 1 is an entity, 2 is the key, 3 is a relationship type. An example of entities from Emily Swap School database that we are going to create who can include the student, the courses, enrollment. Those are just the examples. Well, when we speak about, for example, a student enrolling in a certain course, then enrolls in is a relationship whereby a student enrolls in a course. So if a student is enrolling in a course, it means that there is information within the student's table that is related to another field in the course table. So that then some information in the student's table can be related to some information specific field in the course table. And therefore, ER diagram show what we call cardinality. It can be one field in one table having a relationship with many fields in another table, while we can also have what we call M to M. That is, many fields in one table being or having relationships with the many fields in another table or other tables. So we call that one-to-many relationship or many-to-many. So the following is an entity relationship diagram that is representing or indicates how various fields are related between one table to another in the database we are going to create, which is a MediSwap school database. It shows all the tables that our database will have, the fields in them, and the relationships. Note, what I'm calling tables, you can call them entities. You can call them entities. So an ERD diagram is supposed to have a clear picture or an indication on how all your tables in your database are related. And they are related through which fields. Which are the fields from one table to another that have or indicates the relationship. Now, have a look at this ERD diagram. And it is always very important, my dear students and the rest of the learners, for you to be able to develop an ERD before you start creating or building your database. It gives you a clear roadmap of how your database will look like. Which fields will your database have? How many tables? Now, this ERD diagram here, it has the following tables. In other words, this is actually a picture of our database that we're going to create. It has or it contains the following tables. So the first table here, the first table is called enrollment. You can see that is our first table. Our next table is payments. Our third table, courses. Fourth table, students. Fifth table, fees. And the sixth table, programs. I repeat. Before you proceed with creating a database, have a clear ERD. It is this ERD that will guide you in the creation of your tables, creation of your relationships, because that is the foundation for any database. And therefore, the database we are going to design in my sequence or series of presentations and managed database system presentations will be composed of 6 tables. Now, these tables are enrollments, payments, courses, students, fees, and programs. Now, other than the name of the tables that my database will have, and the ERD should have all the tables for your database. Other than that, these tables or this diagram also illustrates the fields that we are going to have per each table. In the first table called enrollments, you can see we have the following fields. We have enrollment ID, we have student ID, we have course ID, we have academic year, and we have the term. Now, what I want you to look here is that each of the tables contains all the fields it will have in our database. The table's course contains the following: the course ID, the course name, program ID, credit hours. These are the same fields that I illustrated or I mentioned in my first presentation, that is part 1 of the 22-part series, which is already posted in MLSwap ICT YouTube channel. The third table that we have is students. The students table contains the following fields: the student ID, first name, last name, date of birth, gender, phone, email, address, phone or program ID, and enrollment date. We have the payments table, which contains the following fields, or which will contain the following fields: payment ID, student ID, fee ID, payment date, amount paid, payment mode. Our next table will be the table called the fees. It will contain the fees ID, program ID, academic year, and amount. While the last table will be called programs. It will have program ID, program name, duration, and department. My dear students and the rest of the learners, kindly note, you prepare your ERD before you start creating the real database. This is supposed to be part of the design of your database. And once you do this, you will not go wrong. Now, there's another thing you want to note, or you should note. When you have created your tables, you have the tables, you have not yet created, this is just a design. When you have decided your tables, the next thing you need to do is to indicate how the tables are related. Now, the relationship between tables is done using specific fields. So, like enrollment table will be related, will have a relationship with the courses table through which field? Through the course ID. You can see the enrollment table has a field called course ID. The courses table has a field called course ID. So the enrollment table is related with the courses table through a field called course ID. So for the courses, we refer to course ID as the primary key, PK. While in enrollment table, we are going to call it foreign key. So you can see there's a similarity between the foreign key field and the primary key field. The field which is being used for the relationship between two tables. In one table, it is the primary key. In the second table, you set it as foreign key. And a table can have fields that have more than one, or a single table may have its fields having several. Let me put it properly. You may have a single table, but a number of its fields have relationships with other tables. For example, the table called program or enrollments, the table called enrollments, as a relationship with courses through the course ID, as we have seen. And you can see this table also is related to students table. Through which key? Through the student ID. So in students table, the student ID becomes the primary key, while the table it is related with, that is enrollment, the same field called student ID becomes the foreign key. So the enrollment table and the students table are related through student ID. So the enrollment table has two fields so far: the course ID, which creates a relationship between enrollments and the courses, and the student ID, which creates a relationship between the enrollments and the students table. At the same time, you can see we have a field here called enrollment ID. That is in this table. But when you look carefully, enrollment ID is not in any other table. It's not in any other table. But this field plays an important role in our database. Let's look at another table. We have the payments table. The payments table, this table called the payment, is related to two other tables, the students table and the fees table. Through what? The payments table is related to students table through the student ID. As you can see, in the students table, the student ID is the primary key. If you check in payments table, the student ID becomes the foreign key. We look at the fees. The payments table and the fees table are related, or they will be related through the field we are calling fee ID. Therefore, in the fees table, it is called primary key. In the student or in the payments table, the fees ID is called foreign key. We move on to courses. The courses table is related to the, or will be related to the programs table. Through what? Through the program ID. So in courses table, program ID is a foreign key, while in the programs table, program ID is the primary key. Also, the students table is related to the programs table through the program ID. So in the programs table, program ID is the primary key, while in the students table, program ID is the foreign key. The fees table is linked to programs table through what? Program ID. Therefore, in the programs table, program ID is the primary key, while program ID becomes foreign key in the fees table. And for this reason, my dear students and the rest of the learners, it is important for you to note that the ERD diagram indicates the following attributes of your database that you are going to create. It is like a roadmap. It is a clear picture of how your database will be structured. So it gives the following information. Number one, the ERD diagram shows the number of tables or all the tables that your database will have. Number two, it indicates all the fields that each table will have. Number three, it indicates the relationships, how each of the tables will be related to the other tables in the database through the specific primary keys and foreign keys. So those are the key, or that is the key information. The number of tables and their specific names. The number of tables and their specific names. The number of fields and their specific names per table. The relationship between each of the table with the other tables in your database. And what will be acting or serving as primary key and foreign keys between the tables. So that is an ERT model. And I would advise that before you create any database, identify first the number of tables you will have, the information that each of the tables will hold, and how each of the tables will be related. So the ERD helps designers think through the structure before building tables, and it prevents missing relationships or duplicate fields. It is always advisable that you create an ERD paper or a tool for your database first, and then you proceed to implement those entities as access tables. It thus helps one visualize how entities are connected. So the second model, we call it the relational model. This is a model in which data is organized in tables that is relations, made up of rows, or what we call tuples or records, and the columns, or what we call the attributes or fields, and the uses keys to link tables. An example from Emily Swap School database that we are going to create include the following tables. Students with the fields we have already looked at, the courses and the fields we have already discussed, the enrollments and the fields that the enrollments table will have, the programs table and the fields it will have, the fees table and the fields it will have, the payments table and the fields it will have. So those are the fields and the tables that our database will have, whereby students and programs tables are linked through program ID, as we have discussed, or students, enrollment, and the payments tables are linked or related through student ID. Then enrollments and the courses are linked by course ID, as you have seen, while payments is linked to fees through the fees ID, and the fees linked to programs through programs ID. Therefore, you create tables and use a relationships window to link foreign keys to primary keys, as we have just seen, through the ERD. For example, in the following model, there are two relations, the employees relation and department relation. The attribute employee number is used to link the two relations. So this is just an example of how a relations or relationship model looks like. So in this model, which is different from the ERD diagram, is that in this model, you have the data itself already filled in the tables. And then you have the field name. Now, the EMP number in our representation here, the EMP number, this EMP number here, these are the fields. This is a field, this is a field in this table. Department number, employee number, and department name are the other fields in our second table. So you can see the difference between ERD model and relational model is that in the ERD, what we had are the tables, the skeleton for the table and the fields it will have, table name and the fields it will have, and the fields indicating the relationship as primary key and foreign key. When it comes to the relational model, you have or you draw the specific table. You indicate the table in form of rows and columns. That is, fields in columns and rows or records. So a complete table with filled fields, as you can see. So this is the first table, and this is the second table. Now, the first table is related to the second table through the employee number, as you can see. Now, one thing that you should note here, you can see that the employee number in both tables, the employee numbers in both tables have a similarity. You have E0023, and that is the one here. This is the one. It is for Dennis. E0034, this one is here. So by the look, you can tell. If you check E0056, it is this one here. And therefore, you can see the data which is common, the common data between these two tables is the employee number. You can see that. And therefore, the two tables are related through employee number. So we have what we are calling two relations. Very important. So you can see in relational or relationship model, we have the tables, filled tables, indicating the records in each of the table and the fields per table. And then we draw a line from one table to the other, indicating the field that has relations. Next, we have what we call the hierarchical model. In hierarchical model, this model indicates a collection of records and how they are connected to each other through links. So a hierarchical database model consists of a collection of records that are connected to each other through links or what we call pointers. Each record is a collection of fields or what we call attributes, each of which contains only one data value. It encompasses one-to-many relationships only. It is a tree-like structure where each child has one parent, like XML. It is not widely used for modern relational database management systems. So how does it look like? It indicates a parent-child relationship. An example from a memory swap is a situation where departments have programs and the programs have courses. So you may have a department has several programs. And under each of the programs, we have several courses. So the highest level in the structure is the department. Under the department, we have an arrow pointing to programs. And under programs, we have an arrow pointing to courses. So this model is ranging for many to many relationships, like student course, where several students take several courses under the courses table. So several students taking several courses, several students taking several courses. And these students belong to specific departments. So we have students in a department with several students taking several courses. In other words, many students taking the same courses or several courses at the same time and at the same or in the same department. It is not supported in Access, but useful conceptually. So the two models that are supported in Microsoft Access are the ERD model and the relational or relationship model. So this is how a network model, that is this model we have discussed, not network but hierarchical. This is how our hierarchical model looks like, just as I've said. So this is hierarchical model, this one. So this is hierarchical model. That's how we represent it. So in this case, I have used a sample department called hospitality. So under hospitality, we have two programs. We have the foods and beverage program and the catering and accommodation programs. Under the foods and beverage program, we have two courses. We have foods course and beverage course. Under catering and accommodation program, which are also under the hospitality department, we have two courses. We have foods course and beverage course. Now, this is an error. This is not foods course. Let me illustrate this. So this is not foods course, but catering course. So this is not supposed to be fees course, but catering course. While this is not supposed to be beverage course, but accommodation course. So let me show you how you correct. If you have such a diagram and you'd like to have corrections, you can do it as follows. So let me correct it, and then I show you how it will look like. So this is our structure now. You can see initially here, I had a repeat of this and this under the catering and accommodation, which cannot be. You always ensure that you have no duplicates. And therefore, the foods course and beverages course are under foods and beverage program. While under the catering and accommodation program, we have two courses. We have the catering course and the accommodation course. So you can see the structure from the overall department to specific programs, and under each of the programs, we have specific courses. So we call that a hierarchical model. And therefore, the next model that we can have is what we call the network model. This network database model allows multiple records to be linked to the same owner record type, or what we call parent record. These multiple linkages allows the network database model to be flexible. In addition, the relationship that the information has in the network database model is defined as many-to-many relationship because one owner record type can be linked to many member records and vice versa. It is meant to improve database performance. This is a graph structure where a record can have multiple parent and child records, making it more flexible than hierarchical, but more complex. An example from a MLSWAP database is a situation whereby a course belongs to multiple programs, and the programs can include multiple courses. It can be represented as network links. Now, it is important, my dear students, to note that network model is similar to hierarchical model, but allows many-to-many relationships. It is not directly supported in Access, but it is relevant for understanding complex relationships. Now, I want you to note this, that when I say that you can have a course belonging to multiple programs, and multiple programs can include multiple courses, I mean, if, for example, you have a unit called communication skills. Now, communication skills is offered to courses or to students pursuing many courses. So you can have within various programs communication. For example, we have ICT program and electronics program. Now, the ICT program can have communication in it, while the electronics program can have communication in it. Now, in electronics course, you can have several courses there, or in electronics program, you can have several courses like electronics or others. And in each of them, you can have communication. So all the students pursuing ICT program, all the students pursuing electronics program can have communication in their programs. Now, those students within that program for ICT can belong to many courses. For example, ICT level 5, ICT level 6, computer science. And within each of them, we still have communication. So in that kind of a situation or scenario, you have what we are calling network model. And therefore, an example is a situation whereby a student can enroll in multiple courses, and each course can have multiple students, in addition to the explanation that I've given. Records are connected as a graph, where each record can have multiple parents and child relationships. So it can look like this. Here, I'm illustrating some courses. Like here, I have circuit analysis course, computer networks course, database system course. Now, these are various courses, and of course, they are different programs. So, like circuit analysis can be for a certain course in electronics. Computer networks can be in a program for ICT, database system, course the same. So we can have students pursuing certain courses, like student one is pursuing circuit analysis course and database system course, as well as computer networks course. While student 3 is pursuing circuit analysis course and computer networks course. Student 5 is pursuing computer networks course and database system course, while at the same time, student 2 is pursuing circuit analysis course and database system course, which is also being pursued by student 4. Student 5 is pursuing database system course and computer networks course, etc. So you can see there's intertwining between the students and the courses they are pursuing. So this forms what we are calling a network model. The fifth type of model is called object-oriented model. In this model, both data and their relationships are contained in a single structure called object. An object includes information about the relationship between the facts within the object, as well as information about its relationship with other objects. The objects with similar characteristics will form what we call a class. For you to be able to understand more about this type of model, whereby database is modeled in form of objects and the relationships, I would like to refer you to object-oriented programming series that is posted in MLSWAP IC YouTube channel, and you are going to see how the objects and the classes work. Its main advantage is that it requires less programming effort because of what we call inheritance, reuse, and extensibility of the code. For you to be able to learn more about what we call inheritance, polymorphism, and encapsulation as aspects of this model, visit MLSWAP ICT YouTube channel, where already you are listening this video or watching this video from, and search for the videos in object-oriented programming series that is already posted, and you are going to see a specific video that speaks about the characteristics or attributes of object-oriented programming, which is a feature of object model. And you are going to learn and see more on the same. The sixth model is called distributed database model. This is a database model in which storage devices are not all attached to a common processing unit, such as the CPU, controlled by a distributed database management system, together sometimes called a distributed database system. It may be stored in multiple computers that are located in the same physical location, or that may be dispersed over a large geographical area, that is over a network of interconnected computers. So the following is a summary for database models. So there's a summary of all the models that you can have, but always remember that the programming language or the program we use to create and manage your database determines the type of model that your database will be making use of. So we have the first one being ER model, entity relationship model. It uses entities and relationships to model data, and we are going to have or create a database called the MLSWAP school, where the entities student, course, instructor can have or can exist. You can have entities like student, course, and instructor, and relationships being the enrolling, student enrolling in a certain course, and an instructor teaching a certain course. So with this kind of a model, you can have students model or students entity being related to course entity through student enrolling in a certain course. And also you can have instructor being related to course and the student, whereby the instructor teaches a certain course that a student has enrolled in. The second model is relational model or relationship model. It represents data in tables with rows and columns. So here you have clear tables with the fields and data field. So for example, you can have students table having columns like student ID, student name, and date of birth. So you can have one table being related to another table through, for example, student ID. Then the other model is hierarchical model. It organizes data in a tree-like structure, where you have the large level being department, under which we have courses, and under each course, we have students. Network model, like hierarchical, is like hierarchical, but implements many-to-many relationships. So for example, in a MLSWAP school database, you can have one course belonging to many departments, and many departments can have the course. We also have what we call referential integrity model. It ensures that foreign keys reference valid primary keys. In a MLSWAP school, we can have a situation where each enrollment, or in each enrollment, we have a student ID, And the student ID relationship must exist in the student's table. In other words, let me put it in an easier way. You can have two tables, the enrollments table and the students table. And both of them have a common field, which is student ID. And the student ID should therefore, this student ID should therefore exist in both. So that ensures there is referential integrity. So in one table, it is a primary key. In the second table, it is a foreign key. We also have what we call entity integrity model. It ensures that each table has a unique primary key, and this primary key or this field should not be empty. It should not be null. For example, in a medicine school, the student ID must be unique and it should not have a null value. So, because this student ID or this field will be being used as a primary key in other tables, or the student ID is a field which identifies a student, then this field should not be empty. It should not have what we call non-null value. We also have another model we call star schema. It is a central fact table with dimension table surrounding it. In other words, if you have fields that are being repeated across several other tables, if you have fields, you have fields that are being repeated across almost all other tables, it is advisable that you put those fields that are being shared by other tables in a central table from which linkages can be established. We call that a central fact table. An example in our database called the Swap School will be the grace table or fact table. Now, this grace table will have a field or fields which are shareable between students table, courses tables, and instructors tables. So we call that a star schema model. The following is an illustration of a database that we have used again, or that I shown you in the first part of the series called MLSwap Hotel. This database is implementing what we call the relational model. So let's look at a database here. Let's start a database. Let's have our database here. This database is called MLSwap School. Now, this database has what we are calling it implements what we call the relational model. Relational model. Because if I click on database tools, and then I click on relationships here, you'll be able to see that this database has relationships. So it has three, you can see I have three tables here. I have the table called customer. I have a table called, that is customer details, customer bill, and customers contacts. Under each of them, we have the fields. So we have the hotel ID in all the three. So that is the primary key to identify the customer. When it comes to customer details, customer bill, and the customer contacts. So this is an illustration that this database is implementing a relational database. Because one of the outstanding characteristics, as we have seen, is that in a relational database, we have a field which is common across several tables. And of course, this can also be part of what we are calling, or this database can be part of what we are calling the ER diagram model, ERD, because it indicates the name of our table, like student details table, customer bill, and the customer's contacts, and the fields in it. Number two, it is indicating the fields in each of the tables. Number three, it is indicating the field which is a primary key. Therefore, my dear students and the rest of the learners, Microsoft Access, whose example of a database I've opened, implements the relational database model. And one of the things that is coming out very clearly is that a relational database model or relationships model must have some relations between one table and the other one. So that's an example of a database implementing a relational database. And it also implements the ERD, because you can easily say that what you can see on my screen for relationships is an ERD. It has three entities: customer details, customer bill, customer's contacts. And it has each of those entities have certain or have relations. And this relation, as you can see, is the hotel ID. Of course, you can see the number of entities here are just three. These are three tables. But in real sense, if you check in my screen, you can see I have customer bill, customer details, and the customer contacts tables. So this is just a sample. You can see there's a table, there's an entity which is not included in my relationship here, which is it. We have the customer table, which is missing here. So if I wanted to add it in our relation, I'll just do it as follows. I want to show you, in as much as we are going to learn about that later. I can just click on where I have show table. You can see show tables, and then I can do it as follows. I can click on edit relationships. And then if I want to create a new relations, I can click create new, and also I can add a table. I can add the customer table. But for the time being, my dear students and the rest of the learners, allow me to paint this part so that I'm going to teach you on how to create relationships and how to add tables in my subsequent presentations. For now, my interest is for you to see this sample of a relationship model or a relational model and what I've called the ERD. Later on, in my subsequent presentations, we are going to learn about how you add tables into your relationships, how you create relationships, and how you also determine the primary keys and how you can also change the relations. And therefore, my dear students and the rest of the learners, we can go back to our presentation and allow me to inform you that with that, we have come to the end of part 2 of the series. You can continue to part 3 of the 22-part series, in which we are going to learn about the merits and demerits of using a database. And with that, I want to congratulate you for learning part 2 of 22 of this series, in which we have looked at how to identify database models in database or in managed database system using Microsoft Access and SQL. You can access the rest of the parts in the series, as well as other computer or ICT videos, by clicking or tapping on MLSWAP ICT YouTube channel below this video. To subscribe to the channel, tap on subscribe button below this video in YouTube, where you are listening it from, by looking at the bottom here of this video. Check where you have the name of the channel, MLSOP ICT. Look at the tab subscribe or subscribed. If it kindly reads as subscribe, kindly tap on it so that it changes to a subscribed. Or if it reads subscribed, let it remain that way. Don't tap it again. You can also join this channel as a special viewer or a special subscriber by clicking on join button, and then you can choose your level of subscription so that you can be able to enjoy more other benefits other than just listening to the channel. And then you follow the steps that you are going to be given after you click on join. For any further correspondence, kindly write it to us through the email mlsup@gmail.com. Thank you very much for listening to me. Let's meet in part 3 of the series, and God bless.